friends, welcome to our YouTube channel. Now in today's class we will learn about the methods through which we can find the coherent sources. Okay, so out of that methods, one of the method it is the biprism method or biprism experiment. Okay, so this biprism experiment is important in the study aspects also and for the making of the coherent sources also. Okay, so in this first we'll discuss about the biprism method and the second method it is the Lloyds mirror. Okay, so at the last we'll consider that Lloyds mirror also. Okay, so observe this diagram here. Here I have shown the biprism. Actually biprism is what? Here two prisms they are connected together to form a single prism. So it is called as a biprism. Okay, so in this biprism it is shown there and a ray of light it is coming from the source towards the biprism. Okay, and one screen it is placed apart from the or other side of the biprism. Okay, now when ray of light it will pass through the biprism as shown here by the ray diagram, we will obtain that output at the screen and screen will represent here or its screen will show us the interference pattern produced by this biprism. Okay, so how we can get this? Here see, the single source by the two edges of this biprism get converted into the two sources, and now these two sources will put forward the lights in the forward direction and we will get here the interference due to these two rays. Okay, so here I have shown the ray of light, and if we extend these two rays, see here the dotted line, if we extend these two rays we will observe that it will the imaginary sources that is the S1 and S2. Okay, actually one source is there, it is moving up to the biprism and from the biprism it will be moving towards the screen. But if we extend in the backward direction that refracted rays, then we will get here the imaginary position for the two sources, that is S1 and S2. Okay, so the distance between these two sources that is represented here as a D, that is nothing but the slit distance or slit width. Okay, so distance between these two it is represented by small d. Okay, now by the help of this three-dimensional diagram I have explained again the same diagram just only for simplification. See here, the biprism is shown at the middle, screen on the one side, and here the source. Okay, so when source of light it will fall on the biprism, we will get such type of region on the forward direction. Okay, so from upper side we will get that shadowed region and from the lower side we will get that shadowed region, and there the interference means the overlapping of these two regions will be there, and we observe there the alternate bright and dark fringes on the screen, that means the interference pattern. I have shown there with the small white and black fringes. W will represent here the fringe width. Okay, for this W is the representation of the fringe width, and the distance between two slits again small d. Okay, now we will see the side view of this experiment. So you can observe here the how the biprism will be there and how these rays are refracting from the prism, and we are getting the interference pattern on the screen. So it is the side view, so we can observe clearly the interference pattern and the experimental procedure during this experiment. Okay, so this is just for the simplification matter I have shown this. Okay, now actually in the experiment how it is arranged, we have to take a optical bench. Optical bench means the instrument, it is just like a bench type, nearly 1.5 meter long. Okay, on this we can mount the various devices, म्हणजे आपण वेगवेगळे डिव्हाइसेस त्याच्यावरती अटॅच करू शकतो. सो ह्या एक्सपेरिमेंटसाठी जे जे लागणार आहे ते आपण त्या मीटर ऑप्टिकल बेंचवरती अटॅच करू शकतो. सो हियर व्हॉट वी अटॅच्ड हियर, सी देयर the source, or we can say that the slit, from the source we are getting that slit, means single slit we have to use here, so we can get the narrow beam. Optical bench वरती ते S slit attach केलेली आहे. In front of that there is a biprism B, and in front of that a lens, movable lens, it is placed, and from where we are observing the interference pattern, that is the eyepiece E, तो त्या साईडला ठेवलेला मीन्स इथे स्क्रीनवर न घेता आपण डायरेक्टली आयपीस मध्ये ऑब्झर्व करणार आहे की बँड्स कसे तयार होतात. ओके, so this arrangement is kept such that center of all instruments that are overlapping with each other, means slit चं ओपनिंग असेल ते, त्यानंतर इथे स्ट्रेट लाईन पण मी ड्रॉ करून दाखवलेली आहे, त्यानंतर बायप्रिझमचा सेंटर, लेन्सचा ऑप्टिकल सेंटर अँड आयपीसचं सेंटर, हे सगळे एका स्ट्रेट लाईन मध्ये असायला पाहिजे. ओके, so this is the arrangement for the experiment. Now in this experiment the lens can be moved in the forward direction or in the backward direction. Okay, and biprism can be rotated about its own axis. Okay, so we are going to rotate this biprism about the axis, and when we will get that axis of the biprism or the refracting edge of the biprism, when it exactly becomes parallel with the slit, then we will get the interference pattern. बायप्रिझम जो आपण टिल्ट करू शकतो, म्हणजे आहे त्या जागेवरती गोल फिरवता येऊ शकतो, असा फिरवायचा आहे की त्या बायप्रिझमची रिफ्रॅक्टिंग सरफेस जी असणार आहे, म्हणजे जिथून रिफ्रॅक्शन कॅरी होणार आहे, दॅट रिफ्रॅक्टिंग सरफेस एक्झॅक्टली स्लिटला पॅरलल असायला पाहिजे. मी मगाशी जी 3D डायग्राम दाखवली होती त्याच्यामध्ये लक्षात आलं असेल तुमच्या, जी रिफ्रॅक्टिंग सरफेस असते आणि दोन तिरक्या असतात जिथून दोन स्लिट तयार होऊन रेज पुढे जाणार आहेत. ओके, सो रिफ्रॅक्टिंग सरफेस जी आहे, म्हणजे आपण नॉर्मल प्रिझममध्ये बेस म्हणतो त्याला. So here refracting surface we have to keep parallel with the slit, and then only we will get here the interference pattern in the eyepiece. त्या condition मध्ये आपल्याला मिळेल. Okay, so how we can find this? By the eyepiece we can find the number of fringes observed as a interference pattern. Okay, so number of fringes जे मिळणार आहे त्याच्यामध्ये आपण दोन फ्रिंजच्या मधला डिस्टन्स with the help of eyepiece we can find, it will be x. Fringe width, here we have to represent here x. Distance between eyepiece is a screen. now screen and slit च्या मधला, source च्या मधला distance काय असतो, capital D, so we can find that also. And how to find small d? For that we are using the lens. This is experimental procedure, so these three measurements we can do with the experiment: x, capital D and small d. Okay, now we can find the wavelength of the ray by using this formula. So biprism चा हा दुसरा पण यूज आहे की we can get the wavelength of the interfering waves. So what is the formula for the wavelength? It is lambda is equals to xg divided by d. So wavelength can be calculated by this formula. So ह्या एक्सपेरिमेंट मध्ये तुम्ही ऑब्झर्व केला असेल की बायप्रिझम इट विल हेल्प अस टू डिवाइड द सिंगल सोर्स इनटू द two sources, and since it is divided with the same source, so these two sources are coherent sources. So here biprism is the first method to divide the source or to convert the source into the coherent sources. Okay, so the next method, it is the Lloyds mirror. Lloyd, name of the scientist, he find one method that only single mirror if we use, we can also get able to get the coherent sources. Okay, so here see the arrangement of that Lloyds mirror, it is shown. Nothing but we have to keep the Lloyds mirror with the horizontal level, and screen is perpendicular to the mirror. Okay, source of light is shown at the one side, means the left hand side, and from there the light are emitting in all direction. So the light which is emitting towards the mirror, that get reflected. After reflection it will move towards the screen, and some lights from the source directly move towards the screen. So these two waves now interfere and form the interference pattern on the screen. So इथं एक मिरर वापरून सेम सोर्स पासून दोन वेव्स, एक स्ट्रेट जाणार आहे आणि एक आफ्टर रिफ्लेक्शन जाणार आहे. सो इथं दोन वेव्स सायमल्टेनियसली रीच झाल्यामुळे तिथं आपल्याला इंटरफरन्स पॅटर्न जो आहे तो मिररच्या मुळे स्क्रीनवरती बघायला मिळणार. This is the second method to find the coherent sources. Okay, so hope you understand both these two methods. Both are used to make the coherent sources, and the biprism is the most important because it is also used to find the wavelength of the So if you have any doubt regarding this, please like our videos, comment here and subscribe.